Okay, so we're talking, like I said, about the HTTP protocol. And its main characteristics are that it's an application level protocol. And this whole idea of level comes from the fact that network communication is complicated in the sense that it encompasses so many things. Right, so at the level of the HTTP, the logic that we're going to follow is that we're requesting resources from a web server. Right? So I'm just going to say something like, get that resource. Right, so there's a high level of abstraction because in order for my request to get to that web server, it has to go through a bunch of servers on the internet. And in order to go through those servers, for example, at some point, it has to be transformed into electrical signal or some sort of, any sort of representation. Maybe it has to be transformed into light or stuff like that. So these two concerns, getting a text resource and transforming the signal into light, right, they're so different, it's really hard to think about all of them at the same time. Which is why network programming and the construction of networks is separated in a series of layers. And you can consider each of these levels of the problem separately, and the layers can be somewhat independent. Right, so my HTTP request, so the communication at the application level, isn't actually interested in how the signal is actually transmitted on a physical medium. Make sense? Right, so I have this separation. There's 7 layers in a descriptive model of networks, and on the application level is where you have the limit is your imagination, and you can build any protocol, including custom ones. Again, like I said, standards are good if people follow them. Now, this is a request-response protocol. What does that mean? Well, whenever I talk about communication over the network, I have to understand that the server handles multiple clients. Right? So how is the server going to know when the communication with a particular client has started and when it has ended? Now, one way of doing this is to make the server request-response. Request response means that only the client can initiate the communication, and the idea is the server listens to requests, it gets a request from a particular client, it answers that request, this communication is over, and then it continues to wait for requests from other clients. It's a really simple way of thinking about separating between the clients. Okay, makes sense? Synchronous communication, which means, again, this doesn't necessarily apply. This is the initial vision of the protocol, and our applications are mostly going to be asynchronous. Now, what would be the difference? So synchronous means that whenever we do a request to the server, we're going to wait for the completion of that request without doing anything else. Like I said, we're actually not going to do that. We're going to write in a style which is asynchronous. But the protocol itself, the underlying protocol works like this. Now, obviously, it's called hypertext. That's because the data transmitted is text. But again, obviously, if I go to a Wikipedia page, I can see that it's not only text. So how did I get the images? Well, in order to get the images on a text protocol, what I had to have happen is for the images to be converted into text and then reconverted into images. And there's an encoding scheme which is called base64, which for every 3 bytes is going to give me 4 ASCII characters. Right? And that's how things are transmitted. When doing this, I have to also transmit the type of the resource that I'm sending, and this is done for something which is called MIME types. I'm going to get to those a bit later. Now, the HTTP protocol is in principle stateless, which means, like I said, each request of the client coupled with its response is a full communication. That's the communication. Make a request, get a response. But again, if I think about something which is completely stateless, it's going to raise a series of problems, right? If I think I go to a web shop and I put a product in cart, and when I click finalize, if it forgets that I have something in cart, the application cannot work. So I have to have some mechanisms to keep state, to maintain state. Now these mechanisms, again, have been thought into the protocol from the very beginning, and they are cookies and sessions. Now cookies, the difference is that cookies are stored on the client, right? So I store the information on the client, whilst in the case of sessions, I only store a key to the information on the client, and the rest, the actual content, is stored on the server. But this raises another problem, right? So where do these keys or these contents fit? Well, I said that the protocol is extensible. The way it's extensible is, and let's actually look at the site of our university. And among the tools that I have here at my disposal, I have a network tab, right? And in the network tab, I can actually see the network traffic. Notice that instead of getting just one page, I got a bunch of things. Now, the reason why I got a bunch of things is that when the browser got the HTML, which is the root of the Acero website, it found a bunch of links in it, right? And it found links to fonts, to styles, to scripts, and it reached the conclusion, let's look at the source, right? So there's a bunch of links in it. So the browser said, well, I probably can't draw this unless I have these additional files. So it requested these additional files. Right, but if we look at one of these requests, we can see what the general shape of a request is. So a request is going to have let's see if we have something where we can see it raw. Let's look at this one. No? We can't see it raw? We can't see it raw. Right, so an HTTP request looks like this. So there's a method, in this case get, then there's an address, what am I getting? There's also the version of the protocol, but it's more or less important. But then there's a bunch of key value pairs, and these are called headers, also the HTTP headers. Now, initially, all these headers were optional. The way this works is, for example, if a client sends a header which the server doesn't understand, the server can just ignore it and continue the conversation as if the header didn't exist. So this is part of what makes the standard extensible. Let's take an example. So for example, in my request, I don't know why I don't see them completely, but in my request, let's go to something simpler. Let's see if we can see this. Right. So in my request, for example, my browser said accept encoding gzip deflate br. Right. So it said, well, text is really useful to compress. Right. Text has a high compression ratio. So if you know how to if you, the server, know how to compress my resource before sending it to me, you can compress it with one of these algorithms, and I'm going to be able to understand it and decompress it. Now, let's say that at some point in the evolution of the web, the server didn't yet have this feature implemented. What it would have done is just get this header, not understand it, and send the resource uncompressed. And because the server, in its reply, which is these headers, wouldn't have said anything about compression, the client would have been able to understand this, and you would have had less effective communication, right? Because it takes a lot longer to transfer the text uncompressed than compressed, but the client would still have gotten its content. Make sense? Right. So this is not only for this header. You can have a bunch of headers. You can define your own headers. Right, if we go to the site of the here, I can see that I have some headers which are like this, right, with columns, the left and the right. This signifies that this actual server uses HTTP 2 because the compression business that we've just discussed only applies in HTTP 1.1 to the body of the response or the request. Right, so it's only what's sent in only the resource. while in HTTP 2 it applies to everything, right? You can compress headers, you can compress everything. Okay, there's another extensibility protocol, extensibility mechanism, and to think about that, we should talk about HTTPS. So you've noticed that some sites you can access on HTTP, some on HTTPS. What would be the difference between HTTP and HTTPS? Well, it's hard to explain because at the level of the protocol itself, they have the same commands, they're identical. And then you should wonder, well, if they're identical, how are they different protocols? Well, they're different protocols by the following mechanism. I was talking about network protocols being organized in layers. Right? So my application level protocol, HTTP, is going to need somebody to handle the rest of the transmission, right? It doesn't know anything which is under it. So it needs something underneath. And that thing underneath is a protocol called TCP, Transmission Control Protocol. Now that protocol is unencrypted. So HTTP uses TCP to transmit data, while HTTPS uses a secure version of that protocol, which is called TLS, Transport Layer Security. Now, something I have not clarified is what do I mean by this protocol business? Well, obviously we're using a communication protocol right now, but this protocol is really hard to describe. Network protocols are a lot simpler, but if you think about it, a protocol is a series of commands of transmission items and the expected behavior to those commands. Make sense? But in the case of HTTP, you have under 10 commands. Whilst if you analyze a natural language-based protocol, we can't even begin to talk about that. Okay. Right, so I said that it's a request-response protocol. All communication is one client request, one server response. You don't have state except for these cookies and sessions. Now, if I look at how cookies are represented, I can I see it on this side? On this side? Yeah, I can see set cookies here. Right. So whenever I get a header with set cookie, it's my responsibility as a client to save that cookie to a special storage, which is generally a text file on the hard drive. And whenever I do the next request to the server, I'm going to add a cookie header myself with the state that I had beforehand. Make sense? So the server sends me something and it tells me, well, you save this, and the next time you come here, show me the cookie. Obviously, they're used for more than that, but this is the principle of it. Okay. So we mentioned the browser being a web client, and then we have the other part of the communication, which is a web server. Now, what a web server is, it's something which delivers minimally, it's something which delivers web resources. Right? Web resources don't necessarily mean files, but they do necessarily mean something which was representable as text content. Now, web servers are somewhat varied in the sense that I've put these examples here to contrast what we're going to do. So the granddaddy of all web servers is called Apache, and it's included in Linux systems, etc. Now what Apache does is what every web server has to do is you ask for a resource via an address. And then, in the simplest case, the web server has to find the file representing that resource, it has to read it, and send it over the network. Okay? Now, obviously the problem, the discussion doesn't stop here, so Apache does a bunch of other things. Most notably, if you need to invoke some sort of script, right, you instead of asking for an HTML, you ask for a PHP script. What Apache is going to do is it's going to try to find a container which is capable of running PHP. It's going to run that script, and the resource it's going to send you is going to be the result of the execution of that script. So it's output, right? It's instead of writing to the console, it writes to an HTML file, and that's what you get. Right. So that's Apache. Now, Pretty simple. It's the general principle of a web server, something like IIS, so Internet Information Services. Now this is a sort of combo server. It also has an FTP server. It's everything in one package. Now what about Nginx? Nginx is something more modern, and it functions like a reverse proxy. Now let's investigate this concept a bit. Do you know what a proxy is? What does a proxy do? Yes, that is correct. I'm going to expand on it a bit though, which is, yes, but you don't only have one user. So the utility of a proxy is that it hides the existence of multiple clients. Right? So you have a bunch of clients, there's only one internet accessible address, that's the address of the proxy, and whenever one of the clients behind the proxy wants to ask for a resource, it's going to delegate to the proxy. Right? It's going to say to the proxy, ask for this resource in my name and then send me the result. Now Nginx is a reverse proxy. So if a proxy hides the existence of multiple clients, something like Nginx is going to hide the existence of multiple servers. Right? So you're going to do the request to the same address, but the actual processing might be done in various locations. And the typical example is if you want to cluster your processing nodes. Right? So let's say instead of running my application on a single server, well, if that single server maybe its hard drive fails, right? I'm going to have discontinuity in service, right? It can't deliver information anymore. So instead, let's say you put 5 servers, and the Nginx selects one of them, but you're under the impression that you communicated with a single entity. Does this make sense? Right. So you can do stuff like load balancing. You can do stuff like high availability. You can construct your own thing. Right. What we're going to write is even more niche, in the sense that we're going to write basically console applications which are web servers. It's a lot simpler than it seems at first sight. So the advantage is they're going to do exactly only the thing that we need. Right? There's not going to be any additional, or they're going to be really lean. Right? They're going to do exactly what we need. Right, so web resources. Web resources are not necessarily files. And I gave you an example in the sense that when I'm accessing a PHP script, what I'm getting is not the source of the PHP script, but the result of its execution. Conversely, when I'm going to be accessing objects, there's no file corresponding to those objects. Right? I get a resource which is constructed, which represents all the, somethings in all the kangaroos in my kangaroo collection. Like I said, the type of the resource is going to be defined from MIME type, and the MIME type is something which predates the internet. It was invented for mail attachments, and it's going to tell me what kind of content was delivered. Now, whoever has a resource has to specify its type, right? So think about it. If I ask for a file from the server has the resource. And when it sends the file to me, it also has to tell me what type it is. If it sends me an image, it's going to say it's image/JPEG. If it sends me HTML, it's going to be text/HTML. However, if I reverse the interaction, and for example, I use the HTTP to save a resource on the server, I'm the one who has the resource, and I have to specify its type. Make sense? We're going to run into this a bit later. Now, there's two perspectives over the resource. There's a remote perspective and the local perspective. And think about what I said earlier. So I asked for a file, an actual file from the server, and the thing I base my request on is an address which has relevance in the internet. But I don't actually know what the file structure, the internal file structure of the server is. So the server has to map my address to something which exists on its hard drive. Well, to address something which exists on its hard drive, it needs a path to it, so it can get a file descriptor to it, so it can read from it, so it can send me the content. So there's two perspectives. There's this perspective that the server has, and generally, what it does is it has a directory which is called the web root, and within that web root there's a structure, and it's going to read files or execute scripts from that particular web root, and then it's going to send them the result of its processing over the network. Make sense? So on the one hand, I have to know that the file is in /home/ something /web root. On the other hand, I'm going to have an address, and it's going to be example com/some file.html. Right, so I said that there's so the path, we understand what that is. It's a path to a file on a hard drive. What about the address? So the address is a standard addressing scheme. Typically, everybody miscalls it URL, which I'm going to do as well. But they're actually uniform resource identifiers, which are composed of a location and the name. So URL concatenated with URN is going to give me the URI. But like I said, colloquially, everybody says URLs. Don't know why, but this is... right. So how does such an address look like? Well, first of all, it's composed out of ASCII characters, digits, and a small set of additional characters, such as minus, underscore, etc. Now, this presents me with a problem, because I can make a file which contains a space. Right? On my operating system, I can create a file which has a name containing a space. Now, a space is not valid in an URL, which means I have to have some sort of encoding. In this case, it's something called percent encoding. So if a character is not valid in a URL, I can represent it by writing %, and then it's the ASCII code calculated in hexadecimal. In this case, %20 is the ASCII character corresponding to 32. It's a space. Don't worry about it, you don't have to do it by hand, but that's what those things mean. If you check an ASCII table, you're going to get this. There's an extension of the standard which allows you to use additional characters, but this is good and bad at the same time. So first off, yes, people in China want to use Chinese characters in the URLs. So maybe that's positive to them. But on the negative side, if I were to give you a Chinese URL to access, you wouldn't be able to write it. Your browser, your operating system, right? You don't have the keyboard for it. How would you write it? Bad example, there's a way to write Chinese characters with Latin letters. It's called Hanyu Pinyin, but you know. So it could lead to fragmenting, that's what I'm saying. Now, the general shape of the URL is going to be the one that you can see here, right? It's the second bullet. So first I have a schema. Now the schema identifies my protocol. Now URLs are used for many more protocols than we're going to discuss here. But what we're interested in is HTTP and HTTPS, right? Like I said, the HTTP and HTTPS protocols are identical, with the only difference that one of them uses a secure transfer layer, HTTP secure, and one of them an insecure transport layer. We're going to get back to this further on. We're going to have a course towards the end of the semester which is going to talk about security. So for now, let's not dive too deeply into the HTTPS business. Then I have the server. Now, what is the server part? Well, it is either an IP, but that's really, really rare, or a name. So how does my browser know who to communicate with? Right? You know? So when I write www.google.com, well, what happens is there's a protocol called DNS, which is going to handle answering one of the following two questions. What is the IP address corresponding to this name? Or what is the name corresponding to this IP address? Okay, so this is the server bed. Is going to probably be a name, which is going to then, in order for communication to be possible, be translated to an IP address, which is a numerical address. Right? The name is something we understand, and the computer doesn't, and the address is something that the computer easily understands and we have difficulty with. Then I have a port. Now, what is this port business? You probably noticed that in this case I wrote something different here, but so it's 8080, but generally I don't explicitly write any port. Now, that's because there are default ports, which are 80 for HTTP and 443 for HTTPS. But what is a port? What's it good for? Well, if you think about it, my computer at this point communicates over the network, and it communicates over the network through multiple applications. Right? Probably. So I can have, at the same time, I can have a Zoom session open, and I can browse the internet, and I can, so I can do multiple things. But if you go on a lower level, so my computer receives, in this kind of communication, some packets of data. And it has to be able to figure out which application is supposed to handle those packets of data. Right? Is it the Zoom thing? Is it the browsing thing? Right? For whom are these packets destined? Right. So I can identify a particular application running on a particular computer via its port. Right? So there can only be one application using a particular port, which is just a number. It's a number between 1 and 65,535, which is you can use any unoccupied port. So the only condition is it has to be unoccupied, because if you were able to have two applications on the same port, it would be useless. It wouldn't be able to differentiate between applications. So that's the port. Then I have a path. Now the path is going to be, I was talking about the server delivering resources from a web root. So think about it. That's a folder, and it can have structure. So it can have subfolders and subfolders and so forth. And I have to be able to refer to where my resources are in relation to this. Then there's a question mark and a bunch of parameters. Now, if what I'm asking for is a file, there's no point for parameters. I can't parameterize that file. But if I'm asking for something other than a file, I might want to send some sort of parameters to it. And to see it in its simplest form, we're going to go to Google, and we're going to search for test. And if you look at the address, you probably don't see anything, but I'm going to copy paste it here. Right? And I know it's a bit more complicated. Let's simplify it. I'm going to delete much of the things which are, are noise. So if you see, I sent this to Google. I sent the parameter. What am I searching for? Well, I'm searching for test in this case. Now let's Control Z this. I can have multiple parameters. So it's Q is test, and whatever that is has a value. Right? So there's a list of key value pairs. And the server, obviously, if it understands these parameters, it's going to customize its response based on the parameters I've sent. Right. And the last part is something which is called a fragment. So it's a sharp sign and then a fragment. Now, initially, these fragments were introduced to be bookmarks within large files. Think about having a large web page which contains a whole book, and you want to have bookmarks to the chapter beginnings or something in the structure of the book. You don't want to have something just linear, which is going to be really hard to consume. Now, they're interesting to us for another reason, though, which is we said we're going to write single-page apps. Well, if they're single pages, how do I refer to something, to a state within the app? Well, let's say I have an app, and the app is a cat photo sharing app. How do I refer to a particular cat? Well, since it's a single page, the only thing I can modify really is the fragment. I can use the fragment to be able to link to states within a single page app. Okay, so this is the explanation. Right. Now, something else. So I said that an HTTP request, which is, it looks a certain way. So I apply a method to an address, right, and I get a response to it. Now, what are these methods, and how does an HTTP request look? So my HTTP methods are really a really small set of methods, right? So it's not a huge number of things. It's on the contrary, it's a small number of things, and it's remarkable that I can do something complex with such a small number of things. So options. Now options, when applied to an address, is supposed to give me all the methods that that address supports. Right? So what can I do with it? I can get it, I can post to it, I can do options to know what methods are supported. Now get returns the resource at the specified address. Post, well, post is going to create a resource, a sub-resource at the specified address. So I'm going to say post a kitten to /kittens, and that's supposed to add a kitten. Now, all of these are conventions, and our strategy for building complex applications is highly convention-based. We're supposed to follow these conventions to organize our code, and that's going to make the code a lot easier to write, debug, document, etc. Now, I also have put. So put is going to replace a resource from a particular address. Now this means edit by replacement, right? So it's just going to replace it. Delete is going to delete a resource from a particular address, and patch is going to be more of what I generally think for editing. So it's not going to replace the resource, rather it's going to directly modify it. Let's ignore patch, and let's look at these four. So get, post, put, delete. Well, if I squint, I can see that they're actually if you know the CRUD operations on an object, right? So create, read, update, delete. They're actually that, right? So create is post, read is get, update is put, and delete is delete. Right. So we're beginning to see a strategy, right? Because if the address represents an object, I can have the fundamental operations on the object using only the HTTP methods. Now this is the basis of what we're going to do with RESTful services. Now the HTTP request. So HTTP requests can be described in a really simple fashion. We're going to talk about requests and responses and going to end it after that. Which is going to be a request line, which is going to be a method, an address. So get that particular address. It's also going to have the protocol version, but we're going to ignore that. Then a number of headers, if they're not compulsory in any fashion, right? So I don't have to use headers. But if I want more complex behavior than the default behavior, I might want to use headers, right? Maybe I want to request a resource, and I know that the server knows how to give that resource in different languages. I'm going to use a header to tell it, give me the version of this resource in English. Maybe I want it compressed. Maybe so. There's a bunch of things that I can use to extend the behavior. Then I have an empty line, which is part of the standard, and then I have the request body, if that exists. Now, if I do a get, the request body doesn't exist, right? Because I'm asking the server to give me a resource. I'm not sending anything to the server. There's no point to it. But if I do a post, the request body has to exist, because I'm trying to create a resource. How would the server know what resource to create? Well, I have to send it something to be able to derive that resource, to understand that resource. So this varies from one to another. Now the server is going to answer with something. Now there's a bunch of these codes, but what is interesting, so what is important, is the first digit. Right, so there's not a single 400 something, there's 400 bad requests, 401 unauthorized, right, so there's a bunch of them. But what I actually have to, sure, it's a good idea to reply with the appropriate code, because it explains what happened. But what I have to take care of is to reply with the appropriate class of code, because various APIs are going to assume stuff. Right? So if I make a request and I get something with code 200, but it's actually an error page, my application is going to be super confused. But if I get an error page with the code 400, I know it's an error. So I'm saying, so I have to respect the class of the code. What the code is, less relevant. And I'm not saying this from my own imagination. Rather, this is how the standard is written. So if I look at HTTP error codes, I'm going to see something strange. If I look here. There's a code which is placed here to drive a point home, which is 418. I don't know if it's visible, probably not, but see that 418 is I'm a little teapot. Right? So the idea here is there's no condition defined for this, obviously. There's no condition in which the server has to reply with I'm a little teapot. But the idea is that if you have a circumstance which justifies another error code, as long as it's in the correct class, feel free to use it. See what I mean? I mean that's the message here. You can invent your own error codes. They didn't write an exhaustive list of codes. You can invent your own as long as they're in the right class. Now, right, so 400 is client-side error. That means errors which the client could correct, conceivably. 500 is server-side errors. This means errors that the client cannot correct. And 1, 2, 3, let's see, so 200 something is a success code, so the server did deliver a resource or did perform your operation. 300x is redirect. That means the server tells you, I don't have the resource, but I know where you can find it. And the most frequent case you're going to see this is in caching mechanisms. So for example, if I request an image, my browser saves the image after getting it on the hard drive. And provided I use particular headers, the server can tell me a 304 response in which it says, I don't have the resource, but you can find it on your own computer. Right? So it's a redirect to self, which is useful because I don't have to retransfer the image over the network, which might have been a large image, I don't know. And 100 are informative codes. Now these are used in various mechanisms because, and we're going to end with this, because one of the second extension mechanism which we've not necessarily talked about is connection upgrading, which is I can make an HTTP request and within that request say I don't actually want to use HTTP. I want to use something else. And the negotiation for this is going to be done with 100 codes. The typical two cases are the following. I make an HTTP request and I say I don't want to use HTTP, I want to use HTTPS. Right? I want to upgrade the connection to something secure. And if this doesn't work, I might not want to communicate insecurely. And the second one is something which is called WebSockets. Now within this presentation, there's the idea that only the client can initiate the communication. This is partially true because the secondary protocol has been defined in which we open something which is called the WebSocket, which we're going to see towards the end of the semester. And on that WebSocket, the server can push information to us. Right? This is useful to have notification mechanisms. So for example, if I want to write a chat application, I might not be the only one who initiates changes. Some other chat participant writes something, and I have to find out about it without explicitly refreshing my information. We're going to stop here because we have no more time. If you have any questions. Radio then. See you next time. Where we're going to finish up this discussion, which there's not much more to it, and we're going to start discussing about JavaScript.